Okay, rational functions, let's find intercepts. So y-intercept is when you input a 0, right? For y-intercepts, x equals 0. And for x-intercepts, it's when the whole function equals 0, but we can simplify that down a little bit more and just say it's when the numerator is equal to 0. Because if the numerator equals 0, 0 divided by anything is going to equal 0. So let's run through a couple quick problems on this. We have a factored rational function given to us. If we want to find the y-intercept, remember, y-intercepts occur when x equals 0. So we're going to plug in 0 for each one of our x's. So this will be 0 minus 2 times 0 plus 3 over 0 minus 1 times 0 plus 2 times 0 minus 5. From here, it's just a matter of simplifying down. So let me see, we have negative 2 times 3 over negative 1 times 2 times negative 5. So that'll make negative 6 over positive 10, which both multiples of 2, we can take those out and we can say negative 3/5 is going to be where our y-intercept is at. Okay, next up, our x-intercepts. This is when we want to set the numerator equal to 0, or visualize what value would you plug into this factor to make the numerator equal 0, or this factor equal 0. Since it's already factored, if this was 0 for this factor, it's multiplied by everything else, would make the entire numerator equal 0. So for our first factor, x minus 2, if we were to plug in a positive 2, it would make this factor equal 0. Also, worth noting, we don't have an x minus 2 on our denominator, so we don't have a removable discontinuity to worry about. X plus 3, our other factor, no x plus 3 in the denominator, so no removable discontinuity. So if we plugged in a negative 3 here, it would make the numerator equal 0, therefore the whole thing, therefore that's an x-intercept. Okay, similar problem here where we have y-intercept, x-intercepts. First of all, finding the y-intercept, we're going to plug in 0 for our x. So we have 2 times 0 minus 1 and 2 times 0 plus 1 in our numerator over 0 minus 2 times 0 plus 3. With a little bit of simplifying down, this shouldn't be too bad. We have 0 minus 1 is negative 1. And 0 plus 1 is positive 1. Over 0 minus 2 is negative 2. 0 plus 3 is 3. So negative 1 times positive 1, we have negative 1 over negative 6, which will simplify down to be positive 1 over 6. All right, for our x-intercepts, recall x-intercepts are when the numerator is equal to 0. This may be a little bit difficult to see, but you could always set the factors equal to 0 and solve down. If you're having trouble visualizing what exactly we would plug in for this x to make this factor equal 0, just set them equal to 0 and solve down. So add 1, divide by 2. So we get x equals 1/2. In this case over here, we're going to subtract 1 and then divide by 2. So we get x equals negative 1/2. So we have two x-intercepts, one a positive 1/2, one a negative 1/2. Hope this helps out as we're figuring out how to find x and y-intercepts of rational functions. It's really not that bad. You just need to know where to look. Good luck.